Ever really think about the absolute magic that happens when you send an email or load a web page? I mean, data just zips across the globe in a blink of an eye. So today, we're going to pull back the curtain on that invisible journey and find out exactly how it all works.
It feels completely instantaneous, doesn't it? But that one little click, it kicks off this unbelievably complex and lightning-fast chain of events. So come on, let's follow a single piece of data from your screen all the way to its destination and see what's really going on under the hood.
Okay, to wrap our heads around this, we're going to use a really simple analogy for the whole thing, sending a package through a global postal service. Right? You've got rules for packing, addressing, shipping, all to make sure your package gets to the right place. Believe it or not, digital communication is a lot like that.
All right, so just like our postal service, you can't just toss a package in a box and hope for the best. There has to be a universal system, a shared blueprint, so that a computer in Tokyo can talk to a phone in Toronto without any confusion.
And that's where protocols come in. A protocol is really just a fancy word for a set of rules that everyone agrees on. To make sure any device, anywhere, can talk to any other device, we use these standardized models. They break down the whole complex process into smaller, much more manageable layers.
Now, there are a couple of these blueprints out there, but the one that really matters, the one that runs pretty much the entire internet you use every day, that's the TCP/IP model. It breaks everything down into 4 key layers, and we're going to follow our data right through each and every one.
Okay, blueprint in hand. Now it's time to actually pack our message and get it ready for the journey. This is where we prepare the data for its big trip across the world.
This is the part you actually see and touch. When you're browsing the web using HTTP or sending an email with SMTP, you're working at the application layer. This is you writing the letter you want to send.
But how do you make sure your message actually gets there, and gets there in one piece? Well, once your message is written, the transport layer takes over. And its star player is a protocol called TCP. TCP's job is to set up a stable connection and make sure your data arrives without any errors, kind of like getting tracking and delivery confirmation for your package. See, sending a huge web page or a big email in one go is like trying to mail an entire novel on a single sheet of paper. It's just not going to work. So, TCP does something brilliant. It chops your data into smaller numbered chunks called packets. Think of it like tearing your long letter into a series of numbered postcards. It just makes everything way easier to manage. So, our postcards are all packed up, they're numbered. What's next? Well, they need an address, right? This next step is all about navigation, giving each and every one of those packets the directions it needs to find its way across the vastness of the internet.
The network layer is basically in charge of all the routing. Think of this layer as the massive global sorting facility for our postal service. It looks at the final destination for each packet and figures out the best, most efficient path to get it there, even if that means hopping across dozens of different networks all over the world.
So what's the address it's looking for? It's the IP address. Every single device connected to the internet has one, and it's unique. In our analogy, the IP address is like the full street address of the building you're sending the package to. It tells the Postal Service exactly which building, in which city, and which country to deliver to.
Okay, so the IP address is awesome. It gets your package to the right city, to the right building, but then what? How does it get from the mailroom to apartment 4B? For that, you need a much more specific local address. And that's where the data link layer comes in. It handles the very next hop in the chain.
And this is the huge difference between a global address and a local one. The data link layer uses a MAC address, a permanent, unique ID that's literally burned into your device's physical hardware. So if the IP address is the building street address, the MAC address is the specific name on the mailbox. It's how your local router knows to deliver that data to your laptop and not your roommate's phone.
All right, our packets are packed, numbered, and addressed for both the building and the mailbox. Just one thing left to do: actually hit the road.
You know, up to this point, everything we've talked about has been, well, invisible. Just ones and zeros inside a computer. The physical layer is where our data finally becomes a real, tangible thing. It converts those digital bits into actual physical signals, electrical pulses, radio waves, or flashes of light that can travel through the real world.
So you've got your guided media. That's the physical stuff you can actually touch, like the copper wires in an Ethernet cable, or the super fast glass strands in a fiber optic cable. And then you've got unguided media, which is just a fancy way of saying wireless, like the Wi-Fi signals zipping through the air all around us as radio waves.
And then
Once those signals hit the destination, the whole thing just happens in reverse, like watching a movie backwards. The physical layer turns the signals back into bits, the data link layer checks the local address, the network layer confirms the global one, and then the transport layer gathers up all those little postcards, puts them in the right order, and makes sure none are missing, before handing the complete letter back to the application layer for you to read.
So, there you have it. We followed our little packet all the way home. It's a pretty cool technical process for sure, but so what? Why does any of this layered stuff actually matter in the real world?
Well, because each layer has one specific job to do, the whole system is ridiculously robust. Think about it. If one of our little postcards gets lost in the mail, the transport layer can just say, "Hey, can you resend number 42?" without having to resend the entire message. This design is exactly what allows the internet to be both super reliable and big enough to connect billions of devices.
And you know, this whole invisible journey isn't just some cool bit of trivia. It's literally the foundation of our digital world, and it's managed by real people, professionals like network engineers and solutions architects, whose entire job is to design, build, and maintain the very infrastructure we've been talking about.
What's really wild is that this system was designed decades ago, but it's still evolving. And with things like AI getting into the mix, promising to make this journey smarter, faster, and more secure than ever before, you have to wonder, what new doors is that going to open up next?